Algebra 2 trigonometry, absolute value inequalities. The previous video was the equations. This is the inequalities. The solution set of the absolute value of x minus 2 is less than 3. Now, first of all, a quick recap on inequality symbols. Uh, this is the less than symbol, and there's a lot of ways people remember it, whether it's Pac-Man or arrows, or I like to think it's kind of a squished L. But that's the less than symbol. This would be less than or equal to. This is the greater than symbol, and then this would be greater than or equal to. And so we're going to see a lot of those today. So this is the less than symbol, and that makes a big difference. We see in the next couple problems from now, we'll have a greater than symbol. It's very different, and the procedure for solving it is different. So you have to be very aware of what the symbol is. The less than symbol, we kind of treat it like we did the equal sign with the equations in the previous lecture. That what we're going to do is we're going to take what's between our bars, x minus 2, and when it was an equal sign, we set it equal to 3, and the negation of 3, negative 3. So we had negative 3 over here and positive 3 over here, and we had equal signs in between. But we're not going to have equal signs in between this time. We're going to have less than signs in between. The same thing we see here. And now we're going to solve this as an inequality. And solving inequalities is very similar to solving equations. You just have to remember that there's one special rule that if we ever divide by a negative number at any point, then our signs flip from less than to greater than or greater than to less than. But the sign flips if you divide by a negative. Other than that, that's really the only special rule. So to solve this, I'm going to add 2 on both sides, just like we were doing with the equations. Add 2 on both sides. I get negative 1 is less than x is less than 5. And that's it. That's the answer. It's not too bad. This next one has a graphic solution to it. So let me go back to this one. If we were to graph this on a number line, negative 1 and 5 would be the what we call critical numbers, and we'd have circles above them or on the line. I like to do it above, but some people do it on the line. And x is between negative 1 and 5, and what that means is we connect it with a bar. And so as far as solution set is concerned, what we're saying is every number between negative 1 and 5 works in here. Like the number 2, for example. If you plug in a 2 here, you get 2 minus 2 is 0. The absolute value is 0. 0 is less than 3. It's a true statement. But if you plug any number over here like negative 7 or any number over here like positive 7, then it would turn out to be a false statement, like 9 is less than 3 is a false statement, something like that. So you're saying everything in here. Now, these are not less than or equal to signs. They're strictly less than signs. And so that means that the critical numbers negative 1 and 5 are not included in the set. So if you were to list out these numbers, it really wouldn't be too many. It would be 0, 1, 2, 3, and 4. This would be the solution set for this inequality. And that's what happens when we have a less than symbol, is it ends up being between two critical numbers. If we had the equal to bars, then we would include negative 1 and 5, but we don't. So this next one is similar, but it wants a graphic solution. So it's a less than sign and 9, so I'm going to do negative 9 less than 2x minus 1 less than 9. Add 1 on both sides to get negative 8 less than 2x less than 10, and divide on both sides to get negative 4 is less than x is less than 5. Now remember, the one rule, which we haven't done yet, but I'm sure it'll come up at some point, maybe not in the video, but at some point, maybe in tomorrow's class, that if this were a negative 2 and we were dividing, then we'd have to change these to greater than signs. So always be on the lookout for dividing by a negative. So this is our inequality solution. What would it be graphically? So we're looking for a graph that has critical numbers of negative 4 and 5. And that's not it. That's not it. So look at the difference between B and C. This one has open circles. This one has closed circles. We're going to pick the one with the open circles because it's not also equal to. If the equal to bars were there, then it would be closed circles, and the answer were C. And the equal to bars are only there if it's there in the beginning of the problem. So let's try one with greater than now. 3x minus 4 is greater than 5. Okay, so when it's greater than, you have two separate inequalities. You are not going to have a combined. We're not going to do negative 5 and 5 on both sides. You have to write two completely different inequalities. The first one is 3x minus 4 is greater than 5. Exactly what you see up here, just no absolute value bars. The second inequality is still 3x minus 4. Again, we've never done anything that changes what's in the bars, only what it's equal to or inequality kind of thing. So this time it's going to be, instead of greater than, it's going to be less than, and instead of 5, it's going to be negative 5. And so write two completely separate inequalities, one as is, one with the other sign and the negation. And then solve both of these. Let's see, we can add and get 3x is greater than 9 and divide x is greater than 3. And when we add 4 over here, we get 3x is less than negative 1, and then divide x is less than negative 1/3. And so we get two separate inequalities, and if you were to look at this on a graph, and we'll do a graphic one in a minute, negative 1/3 would be on the left and 3 would be on the right, just because a number line goes least to greatest. These would be open circles. There's no equal to bars. It's strictly greater than here, so they're open circles. And then look at these one at a time. X is greater than 3 means 3 and greater. X is less than negative 1/3 is negative 1/3 and less. And so notice that it is not a connecting graph when we start with the greater than symbol. It's arrows away from each other, and we end up with an or statement. And that's how, it's not an and statement, and that's why the answers C and D here are wrong. It is an or statement, because what we're saying is that the values of x, like if you plugged in any number over here, like negative 5, let's see, negative 5, 3 times negative 5, negative 15, minus 4, negative 19, absolute value makes it positive 19, is greater than 5. So all the numbers over here work, or we could pick a number over here. Like if we plug in a 4, 3 times 4 is 12, minus 4 is 8, 8 is greater than 5, so that works over here. So the numbers over here work, and the numbers over here work, but we're saying there's only one solution to x at a time. That's why we use an or statement, because you would say, what is x? Well, it could be a number over here, or it could be a number over here. So it's an or statement. In fact, these would be end statements, because you're saying all the numbers in here work. You know, the numbers less than 5 and greater than negative 1. But I wouldn't worry about thinking about this in terms of end. I would think about this in terms of just between, and this in terms of arrows away with an or. So we're looking for an or statement. Less than negative 1/3 or greater than 3. One more example, but this time let's do it with a graph. So it's a greater than. So we have 2x plus 1 is greater than 7, and 2x plus 1 is less than negative 7. Solving, minus 1, we'll get 6, and we'll end up with x is greater than 3. And then this minus over here, we'll get 2x is less than negative 8, x is less than negative 4. So greater than 3 or less than negative 4. And again, no equal to bar, so we're looking for open circles, and we see the answer A here is appropriate. This is an open circle less than negative 4, an open circle greater than positive 3. If, hypothetically, there was an equal to bar here, then, well, actually none of these answers would be here, but then they would be closed-in circles. But they're not, but I'm sure we'll see some examples that have those equal to bars tomorrow in class. All right, see ya.